Okay, and I am going to review last part of the chapter 3, which may help you to do better during the exam too. Okay, uh, and now, as I said, we still have at least 20-25 minutes. Okay, and as I told you yesterday, the quality control statistics are important to show the quality of the test. Okay, and if you're familiar with the statistics, okay, you may know some of the definitions such as mean, median, or standard deviation. Okay, as you remember, I told you that most of the biological, chemical, and physical measurements, they represent a Gaussian curve, a Gaussian distribution, or a bell-shaped curve, and the distribution of all values around the average for the particular group measures is described by statistically by the standard deviation. Okay, deviation from the median value from the average, and as I showed you, is there. I mean, if you statistically calculate the average value of any test, any measurements, okay, and you also will obtain a deviation of such average, which we call standard deviation. Okay, if you is okay, if you there are, I mean, one standard deviation, 2 and 3 or 4 standard deviation, the confidence intervals means if you accept one standard deviation, what does means uh, if your results fall into one minus and one plus deviation, okay, in this area, uh, and this area will be your confidence intervals. Okay, the other, okay, the other results out of this range, they won't be accepted. Okay, if you accept two standard deviation, okay, above and below the median value, and your confidence interval will be 95%. Okay, for 3 standard deviation, the confidence interval will be 99.7%. Okay, now what does means? In order to follow um, um, the quality of your test, you have to choose one of the standard deviation in order to accept or reject your results. Okay, now, and this is a Levy-Jennings graphs. Okay, as I said, most of the instruments, they are doing this calculation automatically. Okay, however, being a member of the proficiency testing, you have to use such a Levy-Jennings graph for each single methods procedure test. Okay, the Levy-Jennings QC graphical data plots have traditional being used and to identify unacceptable runs, then evaluate the source of the and magnitude of the deviation, and to decide if the result are to be released to the patient's charts or not. Okay, now here you see this is um, a chart, Levy-Jennings chart for only for calcium. As I said, if you have 100 tests in your labs, to monitor the quality of the test, you have to use such charts, okay, either electronically or manually. Um, and this is for calcium. As you see, the median value, the average of the calcium is 12.4, okay, and the okay, and you see the standard deviation of them, one standard, two, and three standard deviation of the calcium. And these are different measurements that you measured in 1 month, okay, from the first day to the last day, okay. And as you see, okay, now here you have a result which is out of the control, higher than the higher level of the calcium. And here you see again out of the control result, okay, which is low. And imprecision, okay, with what does means they are the results are far from each other, okay. Now shift, trends, and dispersions are the terminology that we are using for monitoring of the quality controls. And as I showed you here, shift is defined as a sudden and sustained change in one direction in a control samples. As you see, this is a follow-up of the lab test, one lab test, ACT, okay, which is a liver enzymes, okay, and you have, okay, now here 70 unit per liter. This is a median, and a 1 and 2 standard deviation is accepted to standard deviation. Okay, even though all these results are within 2 standard deviation, however, after day of 7th here, all the data are on the same sides, okay, which we call a shift, okay. It's supposed to be a equal distribution on the both sides, but they are on the same sides, which we call a shift in this case. Okay, here a trend or drift is a gradual change in the control sample results. Okay, each day of the routine clinical lab, you are going to use the control samples. You measure these control samples in order to check your reagents, your tests, your instruments, and your lab technique, your methods, okay? And if your measurements is between 2 standard deviation, okay, you can go ahead and then measure the patient samples. Otherwise, if you have a out of the range of the control samples, you shouldn't release the patient results. You have to stop to analyze the patient sample. First, identify the source of the errors and fix it, and then continue with your patient samples. Okay, now here you see the day of months. They follow the control samples each days. However, after day of 11, okay, the control serum level, even though the same samples, okay, but the result, the level of the control serum is decreased gradually day by day. Okay, that as you see, all the results are within the 2 standard deviation. Okay, the chart is really important to follow the quality of the test. Okay, to notice any kind of the problems, errors before you release the patient's result. Okay, which this is known as trend or drift. Okay, and Westcott rules that we are using either accept or reject the patient results, the test results. And as we see here, okay, there are a chart for Westcott rules. Okay, you follow these charts. Okay, what you should do. Okay, as you see here, one, okay, 2S standard deviation means you exceed the QC result only one time, which is about 2 standard deviation. Okay, and then what you should do, you have to follow these charts. Okay, let's see QC in control report result. Okay, I'm going to show you with another diagram just in a few minutes. Okay, as I said, Westcott results define specific performance limits for a particular assay and can be used to detect both random and systematic errors. There are type of errors in the labs, and if a violation of Westcott rules occurs, actions to take are as follow: accept the result of the testing run if only a warning rules is violated. Okay, reject the result of the testing when a mandatory rule is violated. Now, I am going to show here, okay, the warning rules. Okay, if you accept 2 standard deviation and one of your control is only one of your control is exceed 2 standard deviation out of the 2 standard deviation range, and you have to, as you see here, if one control is exceed 2 standard deviation, okay, the quality control result do not violate any other rules. You have to check other controls, and then if one of the 2 results is violated 2 standard deviation, then the control results are accepted. Now I'm going to show here this. As you see, this is level 1 glucose control, level 2 glucose control. There are 2 control samples of glucose. One may be a low level of glucose. This is higher level of glucose. You are using both control samples to measure the glucose daily and follow it on the chart, Levy-Jennings chart. And as you see here, okay, at the day of fifth here, you exceed the 2 standard deviation, right? At the same day, you have to check other controls. As you see here, the day fifth, the second control is within the normal range. That means this is a warning rule, is not violated the Westgard rules, and you will accept these controls and continue with your patient samples. Okay, if one of your controls exceed 3 standard deviation, as we see here, 1, 2, 3, and day of 7, one of your control is exceed the 3 standard deviation. What does means, okay, this is rule 1,3S rules. 1 times exceed the 3 standard deviation, this is a violation. You should stop to study a sample, patient samples, and first find out the source of the error, fix them, and then continue with your patients. Okay. Okay, a multi-rule QC procedure uses 2 or more statistical tests to evaluate the QC data. Then you reject a run if any one of these statistical tests is positive. And okay, as I said, Westgard multi-rule procedure is designed to improve the power of the QC methods using plus or minus 3 standard limits. If it exceeds 3 standards, then that means is violated the Westgard rules. You have to stop working with the patient's samples. Okay, this is about individualized QC plans. The IQCP is the clearest QC procedure for an alternate QC options. Okay, permit the laboratory to customize its QC plans and include risk assessments and QC plant and quality assessments and by itself. Okay, now let's. I have a few questions for you. Then we will finish for today. Okay, Levy-Jennings plots show values on a chart, have 3 warning rules, have 3 mandatory rules, all above, none of the above. Okay, send your answers. Hi, Saria, Trinity, Isaiah. Levy-Jennings plots, Levy-Jennings chart. We are using this in our daily clinical lab work. Let's see, okay. All above is correct answer, good. Okay, this is a 1 to S, okay? refers to control rule that is commonly used with Levy-Jennings charts. Okay, 1 to S. Okay, what does means if the one control sample is exceed to standard deviation. Okay, let's see. I am going to show you. Okay, when the control limit are set as the mean of two standard deviation, okay, is referred to 1 to S ref, okay, rule of the Levy-Jennings charts. Okay, that should be enough for today.